Question of the Week from the Naked Scientists.
Hi there, my name is Marika Ottman, and this week we're weighing in on a question from Chris Taylor that is out of this world.
3, 2, 1, 0, and liftoff!
If there's no gravity in space, then how do astronauts weigh things?
Weight is calculated by multiplying mass by the acceleration due to gravity. In space, however, there is very little gravity, also known as microgravity. So perhaps the more important question to be asking is, how do we measure mass in space? On the forum, Janus suggests that since mass does not depend on gravity and weight is really just a measure of the force of gravity acting on your mass, they just provide another type of force to replace gravity. Well, who better to ask than someone who has been weighed in space themselves? I spoke with former NASA astronaut and commander of the International Space Station, Michael Foale, to assess the gravity of the situation.
Normally, we do not weigh things in space, and we use density and volume to estimate mass. However, knowing an astronaut's mass during a long expedition to the International Space Station is critical to understanding how humans can endure microgravity. On the ISS, I used a device called the Body Mass Measuring Device. It was actually built in Russia. There's also a US device called SLAM-D, which stands for Space Linear Acceleration Mass Measurement Device. Both the methods are similar, and they measure the inertia of an object by shaking it.
Inertia is Newton's first law of motion. It states that an object in motion will stay in motion unless acted upon by an external force. So let's say you're in a car and it stops short. Your body will keep moving forward and stay in motion until your seatbelt stops you, which acts as the external force. Your inertia is the measurement of how much your body resists the seatbelt and is directly proportional to your mass.
The method for measuring human mass involves oscillating the person on a table attached to a stiff spring, given an initial amplitude of about 0.3 meters. Once the mass, i.e. the human, is set in motion, the period of the motion is timed, around 3 seconds, and used to determine the mass, which is proportional to the square of the period of the oscillation.
So imagine wrapping yourself around the top of a mechanical pogo stick that moves up and down rhythmically. You'd best hold on tight.
The trickiest part of the operation is getting the person to be as compact and as rigid as possible during the measurements, because they're being shaken around. The accuracy of the measurements is roughly plus or minus a kilogram. When I first tried to use it, I found I moved too much involuntarily. After some practice, though, I could get 3 consecutive measurements to be within a kilo of each other.
Thanks, Michael, for that stellar answer. Next week, we're battling boredom with this father and son duo.
Hi, Naked Scientists, this is Thea Hall.
And Simon Hall.
And we would like to know why people get bored.
And what's the evolutionary advantage of boredom for humans?
If you want to share your thoughts on this, email Chris at thenakedscientist.com, find us on Facebook, tweet at Naked Scientists, or join the debate on the forum. That's thenakedscientist.com/forum. Until next time, goodbye!